Special angles. All right, so we had previously talked about the sine and cosine values for the 90-degree angles. So we talked right here about 0/360 degrees, 90 degrees, the cosine and sine values. We did that for all of those 90-degree angles. But if you remember back to our unit circle, it's made up of a lot of spokes, right? And with the spokes on the inside, we need a little bit more geometry to find the coordinate points that are missing. So let's start with a 30-degree angle. We'll go ahead and let you know what, let me make it a little thicker. There we go. All right, so 30-degree angle, something like this, 30 degrees. You would have a point right here, x comma y. That'll give us our sine and cosine values. So how do we figure it out? With the other ones, it was easy. It just landed straight on this axis and you just, boom, took the 1 or the 0. But with 30 degrees, we have to be a little tricky here. Now, there's a few things we can do. So I know that this distance right here is going to be the x value. The x value. And this distance right here is going to be the y value. This is the start of a very tricky geometry proof here. Now, I would never anticipate you coming up with something like this on your own. This is really for your enjoyment. Come enjoy some math with me, if you will. This is really, really tricky, but it's really cute how it comes about. So here we go. All right, so we're going to take this triangle here. This fun, awesome triangle. We love it. It's our best friend. It goes over here. I'm going to go ahead and make it a little bigger. Maybe not that much bigger. There we go. And we said we had that this side was y. This side was x. So this distance right here was x. This distance right here was y. And this is a unit circle. So we know that the radius of a unit circle is 1, which means that this side, the blue side, is 1. We also know that this is a 30-degree angle. 30-degree angle. All right. Well, this is also a 90-degree angle. And with that information, we can find this missing angle up here. So there's 180 degrees in a triangle. We have a 90-degree angle and a 30-degree angle. So if we subtract those out, this is a 60-degree angle. All right, that's cool. This is the tricky part here. So what we're going to do is we're going to draw another triangle. And this triangle is going to be the same triangle, the same triangles we have up here, but just reflected. And I'm going to make it, let's see, a little less thick there. Boom. All right. So if you can imagine, just imagine this is like the spine of a book and you were closing these two triangles in on each other, how these ends would meet right here. So this angle here is going to be the same as this angle here, this 30-degree angle. So let's see, this will be 30 degrees right here. This will be a 90-degree angle. And this down here will be a 60-degree angle. You might think to yourself, well, this doesn't seem to have gotten us any closer to an answer to what the X and Y values are. But we're getting there. We're getting there. All right. So this right here is a 1 as well, right? And this is a Y. Both of these sides, I mean, this is the same side for both of them. It's an X. So this distance from boop, 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 here to here is Y. This distance from here to here is Y. I would like for you to note that that means that the entire bottom side is 2Y. That's very important. Let's just zoom in here. Why not? Okay, cool. So then, where should we go? Well, if you're looking at this, you may notice something special about the big triangle that's been formed. There's a 60-degree angle, a 60-degree angle, and then these two together, they also make a 60-degree angle, right? Those are a 60-degree angle, which means that this really big triangle out here is a equilateral triangle because all sides are the same. So, well, all angles are the same. All angles are the same, and if all angles are the same, all sides are the same. So any triangle where all the angles are the same, which would be a 60 degrees in each of the corners, 60 degrees. With triangles like that, all the side lengths must be the same too. So this is one, and this must be one, which is interesting because we also said it was equal to 2y. And that's what actually allows us to solve for y. Y has to be 1/2. Divide both sides by 2, right? Divide by 2, divide by 2, boom. You get y is equal to 1/2, which is great because that's half of the battle. Half the battle is gone once we know that. So if y is 1/2, if you look at this triangle down here, this boom, 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 this triangle, let's see, down here, we have a hypotenuse, we have an opposite side, we have a right triangle. We can find the missing side length here. We can find the missing side length in this triangle. So 1/1/2. This is a missing side. We'll call it x. We'll use the Pythagorean theorem. So A is going to be one of the legs. I'll just say that A is x and that B is 1/2. C is 1. A squared plus B squared equals C squared. X squared plus 1/2 squared is equal to 1 squared. I'm going to subtract the 1/2 squared on both sides minus the 1/2 squared minus 1/2 squared. You know what? I'm just not even going to write it there. It's going to take up too much space. Boom, boom, boom. If I subtract it off both sides, I get x squared is equal to 1 squared minus 1/2 squared. Taking the square root on both sides. When we do that, there's very technically a plus or minus sign that comes out, but all side lengths are positive, so this is going to be positive. And then this will be the square root of 1 minus 1/4. 1/2 squared is 1/4. So 1 minus 1/4, which is 3/4. So this becomes square root of 3 over square root of 4, which is 2. So x is 3/2. So boom. Not 3/2. That's not what I meant to say. X is square root of 3 over 2 is what I meant to say. Square root of 3 over 2. There you are. All right. So now we have the x and y values. Now we can talk about sine and cosine. I ran out of room over here. Well, there's still some room over here. Let's just make ourselves a little bit of a box over here. Some space, if you will, wherever you have space on your paper. All right. So cosine of 30 degrees. Remember, cosine is the x value. So the important thing here, cosine of an angle is the x value. Sine of an angle is the y value of the point where the terminal side of that angle meets the unit circle. So cosine, x value. The x value is, let me write it right here too, root 3 divided by 2. And sine of 30 degrees is equal to 1/2. That's the y value, 1/2. We can also do these in radians. In radians, 30 degrees is pi over 6. So cosine of pi over 6 is root 3 over 2. And sine of pi over 6 is 1/2. All right. There's that first one. I promise this one's the worst. The other ones, the next one uses some tricky geometry. The last one is very straightforward. All right. The 45-degree angle. The 45-degree angle. This is a point X comma Y. This is the angle 45 degrees. Once again, we are going to be looking for X coordinates and Y coordinates. So this right here, I hope you cannot hear my dog barking. I'm sorry. He's a little upset because we have someone doing some work in our backyard. Please don't bark, Archie. All right, so this distance down there is X. This distance here is Y. And we have a triangle. We know that the radius of the unit circle is 1, so this distance is 1. And then it's like, okay, well, what do we do? Well, we take this triangle out and we look at it further. We're gonna pull it out and look at it closer. So if this is a 45-degree angle and this is a 90-degree angle, this remaining angle up here is findable. There's 180 degrees in a triangle. We have a 90-degree angle and we have a 45-degree angle. If you do that math, you are going to be left with a 45-degree angle. Now you have a triangle where two of the angles are the same. And I wish I had a little more space here to write notes. Maybe I'll just insert a page. Sorry, there's not a page here for you, but I don't know, squeeze it in somewhere. The note I want to make, so an equilateral triangle, equilateral, is it equa? Hold on, spell check. Oh, okay, there we go. Equilateral, equilateral triangle has all angles 60 degrees. Ooh. All angles 60 degrees and all side lengths the same. And if you have one of these, you immediately have the other. So if you see a triangle and all the sides lengths are the same, that means all angles are 60 degrees. So if you have this, you get this. And likewise, if all the angles are 60 degrees, you immediately get this. You get that all side lengths are the same. An isosceles triangle, which I love to spell because I get to say isosceles. An isosceles triangle is going to be a triangle where two of the angles are the same, at least two. And in that case, the sides opposite the angles that are the same will be the same length. So if I draw a triangle like this and it decides not to, let's say I draw this triangle right here and I just tell you that this angle right here is 50 degrees. Let's see. Let's do 70 degrees. What if this was 70 degrees and this was 70 degrees? This guy up here, he's going to be 40 degrees. But these two angles down here are the same. So the sides opposite them, this guy here and this guy here, these two sides are going to be the same length. So this side and this side must have the same length. So I'm going to come back up here to this. This is an isosceles triangle. That means that the side opposite this 45-degree angle and the side opposite this 45-degree angle, they have to be the same length. Initially we said that this distance, it's all right. iPad, we can make it. We said that this distance was X. We said that this distance was Y, but I'm just going to call them both X because they have to be the same length. So I'm going to call them both X. And we know that the hypotenuse is length 1. We have everything we need to solve for X. So we have one of the legs is X. One of the legs is X. The other leg is X. And the hypotenuse is 1. So if we do a squared plus b squared is equal to c squared, we get x squared plus x squared is equal to 1 squared. X squared plus x squared is the same thing as 2x squared, and 1 squared is just 1. Divide both sides by 2 to get the x squared by itself. We get x squared is equal to 1/2. Taking the square root on both sides, I'm going to ignore the plus or minus part because I know side lengths are positive. I say that and immediately write the plus or minus. All right, so it's square root of 1/2, which is square root of 1 over square root of 2. And really, we rationalize this. This is just convention in trigonometry. It becomes 1 over root 2, and then when you rationalize it, you get x is equal to root 2 over 2. If you are having trouble with how I would have gotten from here to here, there's a video on rationalizing denominators from the previous section, so you can catch up on that. But x is root 2 over 2, which is great because x and y are the same. So x is square root of 2 over 2, and y is square root of 2 over 2. Let's see, move it right here. So that gives us that cosine of 45 degrees, the x value is square root of 2 over 2, and sine of 45 degrees is the same thing, square root of 2 over 2. We can do these in radians as well. So cosine of pi over 4 radians, which is the same as 45 degrees, is root 2 over 2. And sine of pi over 4 is equal to square root 2 over 2. All right, last bit is the 60-degree angle, and this one is easy because we've done all the hard work. We have done all of the hard work, and so we are left with not much to do. All right, this is a 60-degree angle. Once again, we have a point right here. It's the point x comma y. We've talked through this a few times at this point, right? Here's this side right here is y. This side right here is x. We pull this triangle out. This is a 90-degree angle. This is a 60-degree angle. This missing angle up here, there's 180 degrees in a triangle. We are subtracting out a 90 and a 60. You're left with a 30-degree angle, which is fun, interesting, and happy for us because we already dealt with this triangle before. Duplicate, bring this down here, erase some of this stuff. All right. Good enough. All right, so we had this triangle here where this angle up here was 60 degrees. That's going to be my dog. All right, sorry about that. So we already did this triangle right down here. And these are the same angles, right? 30, 60, 90. The side, and look, the hypotenuse is also the same. So we can just use this triangle's work to build this triangle. The side, if the hypotenuse is 1, the side opposite the 30-degree angle should be 1/2. So opposite the 30-degree angle should be 1/2. 1/2. Which means that the x value is 1/2. And the y value is the value that is going to be opposite the 60-degree angle. Opposite the 60-degree angle is √3/2. So this is √3/2. And that's all we need to write down the trig ratios here. Or not trig ratios yet, to write down the trig values here. So cosine of 60 degrees is the x value, so that's 1/2. Sine of 60 degrees is square root of 3/2. And in radians, cosine of 60 degrees is pi/3. Cosine of pi/3 is 1/2, and sine of pi/3 is 1/2. All right. So, we did a lot there. But we can use all of this information to fill in part of our unit circle here. So we just finished doing these guys right up in here. With the 30-degree angle, that one was the point, the coordinate point, square root of 3/2, comma 1/2. That's for this point right here. For the point at the pi/4 or the 45-degree, oh, my iPad's dying, at the 45-degree angle, that one was square root of 2, comma square root of 2. And for the pi/3 or 60-degree angle, it was 1/2, comma square root of 3/2. We'll come and talk more about the remaining angles on this page. Well, I guess now, give me a moment. All right, I guess I'm going to go into this now. So we can fill out the rest of the unit circle using this information, and we can do it relatively quickly. So let's go ahead and do that. So I'm going to take this pi/3, and this is another one of the pi/3 spokes. I'm going to take these pi/3 spokes, and I'm just going to use symmetry and my knowledge about the units, just the coordinate system, where things are positive, where things are negative, to put these points in. So I'm just going to copy this guy. I know that there's symmetry happening here, right? When I make a triangle here, this triangle over here, it's still going to have a 60-degree angle right here. It's going to be the same triangle. It's just going to be flipped. So these coordinate points that we have for those pi/3 angles, those are all going to be the same values, just different positives and negatives. In quadrant 1, x is positive and y is positive. In quadrant 2, x is negative, y is positive. In quadrant 3, they're both negative. And in quadrant 4, x is positive and y is negative. So I'm just going to copy this guy. Boom, copy, duplicate. I'm going to move him in right here. And here, I just need to make my x value negative. Duplicate, put him down here. Now they're both negative, so negative x, negative y. And then put this guy right down here and just a negative y. We can do that same thing with the pi/4 angles. I'm going to go ahead and just put them all in first, and then I'll put the signs in. All right, so for For quadrant 2, we need the x value to be negative. For quadrant 3, the x value and the y value are negative. And in quadrant 4, the x value is positive, but the y value is negative. Finally, this guy. Fix up our negative signs. So in quadrant 2, x is negative. In quadrant 3, they're both negative. And in quadrant 4, just y is negative. And let me highlight those spokes. And that's the whole unit circle. So we can talk about these special angles and we can do almost anything using this knowledge. So let's do a quick example. Find the terminal point on the unit circle determined by the following angles. So negative pi over 2. So the pi over 2s are going to be, boom, anything on that little cross there. So negative pi over 2 is going to be right here. That puts you right down here. And the terminal point is 0, negative 1. For 7 pi over 3. For 7 pi over 3, well, 6 pi over 3 would be an entire circle, 6 pi over 3. And so 6 pi over 3 plus an additional pi over 3 would be 7 pi over 3. That brings us right up to here. And our terminal point is 1/2, square root 3 over 2. For these next ones that are in degrees, it might just be easier to make a coterminal angle between 0 and 360. So I'm going to add 360 degrees to 405. I'm going to get negative 405 plus 360. I'm going to get negative 45 degrees. And then I'm going to go a little further and add 360 degrees again to find out where it terminates between 0 and 360. And I get 315 degrees. So where negative 405 lands is the same place where 315 lands. And 315 lands right here. And that's our coordinate point. So that's the coordinate point, square root of 2 over 2, negative square root of 2 over 2. Finally, 540 degrees. Let's do the same thing, minus 360 degrees. So 540 minus 360 is 180 degrees. Excellent. 180 degrees, that's right here. The coordinate point is negative 1, 0. So there's a lot we can do with all of this. I know it's a lot of information there. We will get on to the remaining trigonometric functions in the next section. But hopefully this was helpful and we'll expand on it further in the next video. Bye.